Hello everyone, and I welcome you all for a 2 week online internship program on Demystifying IoT security for digital world. Myself, Santosh Rathod, Assistant Professor from Information Technology Department, Shahanagar Engineering College. In this video, we will be dealing with the introduction to the Raspberry Pi embedded board. So, the Raspberry Pi is a tiny dual display desktop PC replacement, you can say. And here we will be exploring in detail the specifications, the versions, and the pin configuration and the setup in this video. The Raspberry Pi is a remarkable device, a fully functional computer in a tiny and low-cost package. It is known as a single board computer, which means exactly what it sounds like. It's a computer, just like a desktop, laptop, or smartphone, but built on a single printed circuit board. Like most single board computers, the Raspberry Pi is small, roughly the same footprint as a credit card, but that doesn't mean it's not powerful. A Raspberry Pi can do anything bigger and more power hungry computer can do. Now we will go through the different versions of the Raspberry Pi together. Over the years, the Raspberry Pi has evolved, increasing its memory, improving its performance, and adding features. So, which one should you get? So, here we will give the overview that will help you decide. So, here we have listed out the three types: the Raspberry Pi 3 Model B, the Raspberry Pi 1 Model E Plus on the top right corner, and the Raspberry Pi Zero at the bottom. The Raspberry Pi Model B on the top left corner. It is the third generation of the Raspberry Pi. It represents the best all-round Raspberry Pi at the time of writing. It includes 1 GB of memory, 4 USB ports, built-in Wi-Fi and Bluetooth, and an Ethernet port for a wired internet connection. It has 40 general-purpose input or output pins which you can use to connect to your own electronics project. Next, we have the Raspberry Pi 1 Model E Plus, which is listed on the top right corner. It is a cut-down model. It is ideal for projects that needs lower power consumption, typically a battery-based project. It is suitable for robots and projects in remote locations where a wide electric supply isn't visible and batteries must be used instead. It does not have an Ethernet socket and only has one USB port, although you can connect it to a USB hub to use more devices simultaneously. And it does have the full complements of the 40 general purpose input output pins. Then next, the last one, we have the Raspberry Pi Zero. It is extremely lightweight and has 512 MB of memory and one micro USB port. Suppose if you want to use the general purpose input output pins, you need to solder or affix your own pins available separately. So here we have just dealt with the some of the versions of the Raspberry Pi. Then next we have the Raspberry Pi Zero W model, which is the one listed at the bottom. The Raspberry Pi W has an added Wi-Fi and Bluetooth, and it is compatibility with the Raspberry Pi camera module as well. So here we will not be going in detail about the further versions of the Raspberry Pi. There are different versions available with the A and the B model as well. Here we see the typical structure of an Raspberry Pi board, wherein you can see the general purpose input output pins for connecting electronic components. Then we have the Ethernet port, then the USB ports, an audio jack, a camera port module, HDMI ports, the micro USB power supply, and the micro SD cards. Now we will dive deep into the different components of the Raspberry Pi. Like any computer, the Raspberry Pi is made of various different components, each of which has a role to play in making it work. The first and arguably most important of these can be found just above the center point on the top side of the board, which is covered in a metal cap, and we call it as the system on chip. As the name says, system on chip, it's a great indicator of what you would find it priced the metal cover of, a silicon chip known as the integrated circuit, which contains the bulk of the Raspberry Pi system. This includes the central processing unit, commonly thought of as the brain of the computer, and a graphic processing unit (GPU), which handles the visual side of the thing. Then next, we have the random access memory, which is the brain of the system. A brain is no good without memory. However, and just to side of this system on chip, you'll find exactly that. The another chip, which looks like a small black plastic square, and this is the Raspberry Pi's random access memory. When you're working on the Pi, it's the RAM that shows you what you're doing. Only when you save your work will it be written to the micro SD card. Together, this component forms the Pi's volatile and non-volatile memory. The volatile RAM loses its content whenever the Pi is powered off, while the non-volatile micro SD card keeps its content. At the top right of the body, you'll find another metal lid covering the radio, the component which gives the Raspberry Pi the ability to communicate with devices wirelessly. The radio itself acts as two main components. In fact, a Wi-Fi radio for connecting to computer networks and a Bluetooth radio for connecting to peripherals like the mice and for sending data to or receiving data from nearby small devices like sensors or smartphones. Then we have the another black plastic covered chip can be seen onto the bottom edge of the board, which is just behind the middle set of the USB port. This is the USB controller and is responsible for running the four USB ports. Next to this is even a smaller chip, the network controller, which hands the Raspberry Pi's Ethernet network port. Then we have a final black chip, smaller than the rest, can be found a little bit above the USB Type-C power connector to the upper left of the board. This is known as the Power Management Integrated Circuit or PMIC, and it handles turning the power that comes in from the micro USB port into the power to the Raspberry Pi, which needs to run. Now, moving further, we'll be looking after the Raspberry Pi's board. The Raspberry Pi has a range of ports, starting with four universal serial bus ports, okay, to the middle and right hand side of the bottom edge. These ports let you connect any USB compatible peripherals from keyboards and mice to digital cameras and flash drives to the Raspberry Pi. Speaking technically, there are two types of USB ports. The one with black parts inside are the USB version 2.0 ports based on the version 2 of the Universal Serial Bus Standard. The one with the blue parts are faster with the USB 3.0 ports based on the newer version. To the right of the USB port is the Ethernet port, also known as network port. We can use this port to connect the Raspberry Pi to a wired computer network using a cable with what is known as an RJ45 connector on its end. If we look closely at the Ethernet port, we'll see two light emitting diodes at the bottom, and these are the status LEDs, and they let us know that the connection is working. Then next, above the Ethernet port on the left-hand edge of the Raspberry Pi, we have is a 3.5 mm audio-visual jack. This is known as the headphone jack as it can be used for that exact purpose. Then directly above the 3.5 mm AV jack is a strange looking connector with a plastic flag which can be pulled up. This is a camera connector, also known as the Camera Serial Interface (CSI). This allows you to use the specially designed Raspberry Pi camera module. There are micro high definition multimedia interface ports, which are the smaller versions of the connectors that you'll find on your games console, set-top box, or TV. As the multimedia part of its name tells you that it carries both audio and video signals, while high definition tells you that you can expect excellent quality. You'll use this to connect the Raspberry Pi to one of the two display devices, a computer monitor, TV, or a projector. Above the HDMI port is a USB Type-C power port, which you'll use to connect the Raspberry Pi to a power source. The USB Type-C port is a common sight on smartphones, tablets, and other portable devices. While you could use a standard mobile charger to power the Pi, for best result, you should use the official Raspberry Pi USB Type-C power supply. Further, at the top edge of the board is another strange looking connector, which at first it appears to be identical to the camera connector, though it's the exactly opposite. It's a display connector or a display serial interface designed for use with the Raspberry Pi Touch display. Here you can see both the display serial interface and the Raspberry Pi Touch display. Then, at the right-hand edge of the board, you'll find a 40 metal pins split into two rows of 20 pins. This is the GPIO, or in other terms, the general purpose input-output header, a feature of the Raspberry Pi used to talk to additional hardware from LEDs and buttons all the way to the temperature sensors, joysticks, and pulse rate monitors. Then, just below and to the left of this header is another small header with four pins. This is used to connect the power over the Ethernet, an optional add-on which lets the Raspberry Pi receive power from a network connection rather than the USB Type-C port. Then there's one final port on the Raspberry Pi, but you won't see it on the top. Then we have to turn the board over and then we'll find a micro SD card connector on the opposite side of the board to the display connector. This is the Raspberry Pi storage. The micro SD card inserted in here contains all the files that you save, all the software you've installed, and the operating system that makes the Raspberry Pi run. A powerful feature of the Raspberry Pi is the row of the general purpose input output pins along the top edge of the board. A 40-pin general purpose input output header is found on all current Raspberry Pi boards. Any of the general purpose input output pins can be designated as an input or output pin and are used for a wide range of the purposes. To work, the Raspberry Pi needs peripherals. At the minimum, you'll need a micro SD card for storage, a monitor or TV so you can see what you're doing, a keyboard and a mouse to tell the Pi what to do, and a 5-volt USB Type-C power supply rated at 3 ampere or better. The USB power supply, a 5-volt power supply rated at 3 milliampere, and with a USB Type-C connector we need. The official Raspberry Pi supply is the recommended choice and it can cope with the quickly switching power demand of the Pi. Then next we have the micro SD card with the nodes. So the micro SD card acts as the Raspberry Pi's permanent storage, and all the files we create and the software we install along with the operating system itself are stored on this SD card. An 8 GB card will get you started, though a 16 GB one offers more room to grow. So using a card with the nodes installed on it, that is the new out of the box software which should be pre-installed, will save your time. Then next we have a USB keyboard and mouse. The keyboard and mouse would allow you to control the Raspberry Pi. Almost any wired or wireless keyboard and mouse with a USB connector will work with the Raspberry Pi. Then next we have the micro HDMI cable. This carries sound and images from the Raspberry Pi to your TV or monitor. So with all the peripherals connected, now we will see how we can hook up the Raspberry Pi with its peripherals and the working and connecting it with the software. So here in this simulation, you can see all the peripherals are connected with the RJ45 cable, the micro SD card, the USB cable, the audio jack, and once it's connected, the light will glow on the board. After connecting the Raspberry Pi, it will launch the program, and you have to go with the installation steps in setting up your software, then setting the country, then changing the password, updating the software, and then finally this will launch the Raspberry Pi software. So finally, once the setup is complete, there you restart, and then you will get the finally desktop software for your Raspberry Pi, where you can explore further for working on the Raspberry Pi device. From this workspace area, you can start for creating your project. I hope that this video was useful to you for understanding the Raspberry Pi. Thank you everyone for your patience listening.